Hello, Year 9. Welcome to the first exercise in Chapter 6, and today we're going to be dealing with things called indices. Now, it's important that you understand what indices are. Indices are basically powers, another name for a power. There's actually three words we can use, and so let's just do a quick example. If I did this, 2 cubed. When you look at the number 3 here, that's the power. Sometimes it's called an index, sometimes it's called a power, sometimes it's called an exponent. There's three different words we use for that power. And index, when you're talking about an index, that's one of them. When you're talking about indices, it means you're talking about many powers in different questions. So 3 is called the index or the power, and in year 11 we'll learn that it's also called the exponent, but that's obviously a few years away. Now, as it says here, the index or the power tells you how many times we write and multiply a number by itself. Let's have a look at an example. If we had 2 to the power of 5. 5 is the power. That means we multiply 2 by itself 5 times. So the question becomes 2 times 2 times 2 times 2 times 2, which we can actually do in our heads or use our calculator and end up with an answer of 32. So rather than writing the question in expanded form, we've got three forms here. This bit here is called expanded form because we're just expanding it out with all the times signs. This part here is called index form or power form, and this is called the basic solution or the answer. So you've got three parts there. You've got the question in index form, expanded form, and you've got what the answer is. So let's just review that. What was the number 5 called? It's actually called the index or the exponent or the power. But what about the other numbers, the number 2 and the number 32? Well, the number 2, the number underneath the power, is called the base. The base number is the number under the power, and the number on the end, the 32, is the basic numeral or the answer. Now, we've just got to go over a few terms that we need to make sure you can remember. What is a prime number? Now, you've probably covered these before, but it's quite common for people to forget. Prime numbers are numbers that only 1 and the number itself can divide into evenly. And number 1 doesn't count. So, for example, 3 can only be written as 1 times 3. There are no other numbers at times to give 3, so 3 is a prime number. 4. 1 times 4 gives 4, but so does 2 times 2, so it's not a prime number because there were other numbers other than 1 and the number itself that gave the prime number. So that's prime numbers. A composite number are all of the other numbers. Composite numbers have numbers other than 1 or the number itself that can be divided into it. Like, for example, all even numbers except for the number 2 are composite because 2 divide into it. So an example might be the number 8, because not only is 1 times 8 equals 8, which is required to be prime, but there are other numbers. 2 times 4 gives 8, so it's now composite because there is another pair of numbers. Another one might be 9. You've got 1 times 9, but you've also got 3 times 3. So there's another number other than 1 or the number itself, which means it is not prime, it is composite. Remember, 1 is not classified as prime or composite, it's neither. Now, what's prime factorization? Now, that's when you take a number and you just write it as a whole lot of prime numbers that are multiplied together to give that number. So for example, I could look at the number, let's say I looked at the number 18. What do we know are some of the numbers at times to give 18? 2 times 9 gives 18, doesn't it? But 9 is the same as 3 times 3. So 2 times 3 times 3 gives 18. 2 times 3 gives 6. 6 times 3 gives 18. And 2 is a prime number because only 1 and 2 go into 2. 3 is a prime number because only 1 and 3 can divide into 3. So 18 written as a product of prime factors is 2 times 3 times 3. Let's try our examples now. We need to write a to the power of 5 in expanded form, so that just means we're multiplying a by itself 5 times, so it will be a times a times a times a times a. So there's 5 a's there with multiplication signs in between them. Part B, mn is in brackets and it's to the power of 3, so we're going to multiply mn by itself 3 times, so we get mn times mn times mn. Part C, let's write this in expanded form. Notice now that we've got 2 letters, so let's just leave the 4 out the front and times x times x. There's my 2 x's because there was an x squared, and then y is being times by itself 5 times, so y times y times y times y times y. So there's our answer for writing that in expanded form. Let's try our second example. Now this one says to write in expanded form and then evaluate. Well, 5 to the power of 3 in expanded form means 5 times 5 times 5. But if we have to evaluate that, that just means 5 times 5 times 5 on the calculator. 5 times 5 is 25, times that by another 5, we get 125. Part B says negative 2 to the power of 5. So we have to do negative 2 times negative 2 times negative 2 times negative 2 times negative 2, 5 times. And we'll now look at this and see if we can figure it out. Negative 2 times negative 2 gives 4. Times it by negative 2 gives negative 8. Times it by another negative 2 gives plus 16. Times it by another negative 2 gives negative 32. And of course you can do that on the calculator as well. Let's try part C. 2/3 to the power of 3 means 2/3 times 2/3 times 2/3. You can do it on the calculator, but it's often faster in your head. Do the top numbers. 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. So we get an 8 on the top. The bottom numbers, 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. So we get 8 over 27. But again, you can use your calculator if you're not comfortable, because some of them will be a bit harder and you will need your calculator. Now question 3, or example 3, says we've got to take the following and write it in index form. It's currently written in expanded form. So let's count how many m's I've got. 1, 2, 3, 4, 5. So I'm going to end up with m to the power of 5. The n's, 1, 2, 3. So I'll end up with n to the power of 3. And I've got the number 3 and the number 6. 3 times 6 is 18. So I'm going to write it as 18 because of the 3 times 6. The m's, I said there were 5 of them. The n's, I said there were 3 of them. There's the answer written in index form or power form. What about part B? How many times does 1/4 occur? 1, 2, 3, 4. So it's 1/4 to the power of 4. And 2/5 happens 1, 2, 3 times. So times 2/5 to the power of 3. Now that time sign there is optional. You could actually cover that up and just have 1/4 to the power of 4, 2/5 to the power of 3. The time sign is optional. If it's not there, it's assumed that you read it as being there. Now, writing 72 as a product of prime factors in index form. There's a lot of different ways you can do this, and we're going to use a factor tree. We need to think of two numbers at times to give 72. So I'm going to go for 9 times 8, because 9 times 8 is 72. I could have gone for 36 times 2. I could have gone for any numbers I want. It doesn't matter, as long as they times to give 72. Now what I do is I look at each of these two numbers and say, are there numbers that multiply to give 9, and are there numbers that multiply to give 8 other than 1 and the number itself? That's not prime. So 9 can be written as 3 times 3. What about 8? 8 can be written as 4 times 2. So now let's check them. 3, that's a prime number. 3, that's a prime number. 4's not prime, so I can break that one down. So 4 can be written as 2 times 2. Now we know 2 is a prime number, so I've got at the end of my factor tree, I've got a 3, a 3, a 2, a 2, and a 2. So they're all prime numbers. So 72 is actually just all of those prime numbers multiplied together. So I've got the 3 2's, 2 times 2 times 2 times 3 times 3, and there's my answer. And if I write it in index form, I've got 2 times 2 times 2, I've got 3 number 2's, and I've also got 3 times 3, 3 squared, because I've got 2 number 3's. And there's my answer in index form. Well, it's now time for you to enjoy the beauty of mathematics and get yourself involved in this wondrous world of number and power. Enjoy.